right, here we go, 1-4. Now, we're going to take a look a little bit more at the equations of lines, what we can do with them, how we create them, what kind of information is required for us. Now, we've talked about writing the equation of a line. Y is equal to mx plus b. We know what these variables are. We know what these numbers are, but what does it mean? Well, generally put, when we're taking a look at m, that's going to be our slope. That's going to be our rate of change. Remember when we were talking about marginal rates on the last one? Okay. Average rate of change, marginal rates. It's how it changes from one to the next. Okay? If something is repeated, what happens next? How does it change? The other one is B, initial value, where you start at. And wherever you start at, you're always starting at 0. I mean, you got to think about this. If you would stand up now and you start walking for the door, every step that you took got you closer to the door, right? And if your stride was, say, 2 feet, every step you took was 2 feet closer to the door. There's your average rate of change. How much closer to the door are you getting? 2 feet. Where did you start? Well, you started in your desk. That's your 0. That's the initial starting point. Now, I realize that when we're counting things, we don't necessarily start at 0, then 1, 2, 3, 4, 5. We don't do that. But in a lot of instances, what you want to do is you want to think of your starting point, ground 0, if you want to look at it that way. After you do something, that's when you get 1. So, let's try this. Appliance repair. It says an appliance repairman charges $60 for a service call plus $25 per hour for each hour spent on repairs. Assuming his service charge can be modeled by a linear function, linear function of the number of hours spent on the repair, write an equation for the function. So there's 2 things that we've got to figure out. What is the starting point? Okay. And I always, maybe you haven't heard this, but comments, like when you take something to a repair shop, it costs you $100 just for it, but look at it. Okay. It's going to cost you that regardless, even if they only take 10 seconds on it and say, yep, that's your problem, $100. That's the initial charge. In this case, what's the initial charge? $60. Regardless of what they do, if they come in there, yep, it's junk, they get the $60. Okay. If they're there for hours working on it, they still get the $60 plus whatever they charge per hour. So if they spend 2 hours working on it, how much more are they going to charge you? Another $50 because it's $25 per hour. So when you're looking at these things, you have to look for what is changing and what is going to be static, what you always charge. Now, is that $60 always charged for every hour? No, that's just walking through the door. That's the showing up fee. So always pay attention to that. Now, another little form or formula that is extremely handy to have is this one right here, the point slope form. Very rarely are you given a point and a slope that you can pop into a line, especially when that point happens to be a y-intercept. More often you're given some information and it has to be translated into a point, input, output, and how things change from one thing to the next. And we've played with this equation before. I mean, it's nothing new to you. So Let's try this. Oops. Hopefully I got it. So, so we've got a table down here that gives us the number of drinks, the resulting blood alcohol percent for a 180 pound man. One drink equals, and they give us that information of all that stuff. So, what is the rate of change of the blood alcohol percentage for a 180 pound man? What's changing? This is going up by 1, 1, 1, right? Okay. This is going up by how much? Come on. 0.02, 0.02. Is it all the way across the same? Now, depending upon how you look at these things, I mean, we can go to, slope, y2 minus y1 over x2 minus x1. We can think of this as rise over run. Okay? Another way to think about that is going to be your domain over your range, right? So if I take a look at this, it's changing by 0.02. This is always changing by 1. And as long as this changes by the same thing as this changes, you're okay. So let's see. That means that just simply would be rate of change is going to be 0.02 over 1, correct? Or could I just write it as 0.02? So that's the slope. That's the rate of change. That is how it changes, going back and forth. Now, it says write the equation of the function that models blood alcohol percentage as a function of the number of drinks. Okay. So now we're actually going to have to go through and come up with the equation. It does not matter which one of these I pick. Meaning that if I use point slope form, I could, if I wanted to, use this one right here, or this one right there, or this one right there, and I will come up with the same stuff. So remember, it's y minus what? Point slope form. Nope, y minus, I want the formula. Y minus what? Y1 is equal to m times x minus x1. Now, you should have these formulas memorized. By the time we get done with this course, we will have a lot of these things memorized. But here you go. So that means I'm going to have y minus, let's say 3 is going to be equal to, what did we say our rate of change was? 0.02 times x minus, x minus 0.07. Do I have things put in the right spots? Why? That was the first number, I just took the first number. Why? You're right. Always pay attention to what's x and y. I see this happen quite a bit. Students go through and write it down, first number, yep, second number. These two numbers are switched, aren't they? Make sure that you pay attention to this. More often than not, putting the wrong numbers in the wrong place is what causes most errors. So now do I got the right numbers in the right spots? Okay. So now it's just going to be y minus 0.07 is going to be equal to 0.02x minus, what's that going to be? shouldn't be mystifying you. What's 2 times 3? 6. After all it means is 3 of those, right? Add your 0.07. Add 0.07. And we end up with y is equal to 0.02x. And this is going to be plus 0.01. Does that make sense? Now, I said it shouldn't matter which one of these coordinates I choose, correct? So, let's try this. What happens if I got rid of that, 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 and that? So now, let's say I chose 6. So that means it's going to be 0.13 here, correct? And this is going to be we're just going to be plain old 6 over here, right? So that means I got my 0.13 here yet, and this is going to be 0.12. And I go and add 0.13 to both sides. I add 0.13 to both sides. Do I end up with the same exact equation? Should I? Yeah. Every time that you try it, you're going to be getting the same thing. As long as this and this are constant. Now, eventually, we're going to be running into data where your input is always going to be uniform. 1, 2, 3, 2, 3, 2, 4, 6, 8, whatever. But the results aren't going to be. 9 times out of 10, when you go into the real world and you get data, it's not going to be consistent. Close, but not quite. So, let's think about some other stuff. Okay, 2 points to write the equation of a line. That's not a problem. You just use slope, y2 minus y1, come up with that and grab a point. Again, it wouldn't matter whether I chose the -1,5 or the 2,4. I will get exactly the same thing. Exactly. Otherwise, it wouldn't work very well for mathematics. So, inmate population. Number of people in millions in the U.S. prisons or jails grew at a constant rate from 2001 to 2009, with 1.345 million incarcerated in 01, 1.67 million incarcerated in 09. Can I use that information to go and figure out what the rate of increase was? Yeah. I mean, we got an 8-year time span there, and it went from 1.345 to 1.67. All I really got to do is find the difference, right? Find the difference between the two numbers and divide by the number of years, right? That's it. Nothing more complicated than that. Okay. Now, if I wanted to write a linear equation on that, which point would I want to use, 2001 or 2009? Correct, it doesn't matter. But you might want to just pick on 2001 because it's the lower of the numbers. It's closer to the starting point of what the data is. Okay? Now, says C there, the Pew Center on the states suggests or projected that 1.7 million would be incarcerated in. Does this model agree with this projection? Now, they've got the math down here. They put in 2011. They got 1.685. So was that estimate of 1.7 close? Wasn't a bad estimate. So sometimes you can get by with that. Okay. Now, if I wanted to go and estimate that out to say, well, how many people are going to be incarcerated in 2050? Would this be a good model to go and project out to that? Those of you that are shaking your heads, no, are better off than people that are saying, aha. This data only goes from 2001 to 2009. You go out another 40 years, who knows what the trends are going to be like, correct? things can change. That's really far out. Now, could I get it maybe for the next 10 years? It'd be valid. Could I take it all the way back to maybe 1990? Possibly. But I wouldn't want to use that model to go and identify what the incarceration rates were in the 1930s, would I? Wouldn't be as good. So one of the things to keep in mind that models are really only good around their input, okay? 2001 to 2009. You can extrapolate a little bit on either side. Sometimes that's so. Example 6. Zero slope and an undefined slope. A slope of 0 is what? Horizontal or vertical? It's like this. Remember, it's rise over run. 0 rise over all kinds of run. That would be a 0 slope, horizontal line. Horizontal lines go through which axes? Y. So guess what point you use? Y. So if it's an undefined slope, that means it's a vertical line, right? Which axis does it go through? So guess which point you use? The X. It is just that simple. It is just that simple. Okay. I mean, worst case scenario, if you don't remember it, you plot the point, you draw a vertical line and a horizontal line. You know, one line is going to go through the axis where it's supposed to. The other line goes through the axis where it's supposed to. It's pretty easy to tell, right? There you go. Let's see. Parallel and perpendicular lines. Right down here gets us the information that we want. It just kind of puts everything together on here, right? So, I have the other one down here that I'm looking for. They don't. Hoping they did. Now, you remember what it requires to be parallel and perpendicular. There's 2 rules about the slope. Parallel line is easy, right? If 2 lines are parallel, they have to have what? Same slope. What about if they're perpendicular? Reciprocal, yes, but there's a little bit more to it. Opposite reciprocal. If you can remember those 2 things, you will be fine with it. Okay. So, let's see what we got here. Down here. Now, how in the world do you do that? Worldwide hybrid vehicle sales for the year 2004 to 2009 are shown there. The number of sales can be modeled by the equation. Is that equation anywhere near linear? Some kind of wonky curve, right? Now, is it possible to go and identify the rate of change between 2 numbers? Is it? Or put it this way, if I give you 2 coordinates, can you find the rate of change? If I tell you that year 4 was this and year 8 was this, and it's got coordinate there, you can't tell me that you can't figure that out? Just plug it in, you just do it. Will it fit with that curve? No, it's just going to be a line because you've got 2 points. Now, what they do call this here is, for those of you that are going to go back and do the reading, of course, secant line. Okay? Average rate of change, it says for any function, the average rate of change between 2 points on a line is the slope of the line joining the 2 points. We call this the secant line. Okay? So you pick 2 points on there, you calculate out the slope. identify what the what is. One of the points is, and away you go. Okay. So now this looks ugly. Okay. This is average rate of change. Now the reality is this really isn't all that much different than trying to find the slope given 2 points, y2 minus y1. F of whatever function, isn't that output as y? So f of x is our original function, f of x plus something. Something's changed, different point, different coordinate. That's what it looks like. So, what we are going to do with this is just simply use it to go through and answer questions. So now, on A here, now, this is where it gets a little on the trickier side. That's my function, x squared plus 1. Find that. Okay? Now, do they give you any numbers? No, they do not. So, what that means is we're going to end up having to do this. Our original equation is y, I should say, back up, sorry. Is f of x is equal to x squared plus 1, correct? They want us to find f of x plus h. Now, is it supposed to be that whatever is in that parenthesis gets put into for the variable? Yes? No? Maybe? I mean, after all, if there was a 3 in there, we put 3 in there, we'd square it, add 1, right? So if I got x plus h, just because it's x plus h does not mean I do something different. So this turns out to be x plus h squared plus 1. Now, you're going to have to go through and FOIL this thing out. So that's going to be x squared plus 2xh plus h squared plus 1. How in God's name do I do it that fast, right? Whenever you have something like this squared, first term squared, second term squared, middle term, multiply together and double. What's x times h? xh. And I'm going to have 2 of them. So double. Rather than writing out the whole FOIL and putting the marks in and everything else, that's all it requires. Squared, squared, double. Now, I've got everything just the way it needs to be. They also asked us to find this, f of h plus, or f of x plus h minus f of x. So now, what we're going to do, come on, cooperate, is we are going to go and take f of x plus h and subtract off f of x. So what was f of x plus h? Well, that was x squared plus 2xh plus h squared minus, what's x of h? Whenever you do something like this, parentheses are a very, 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 very good thing. I'm going to put parentheses around this. I'm going to put parentheses around that. Not that it really needs it. It helps. Here is where it counts. Because if we're subtracting, and I just have x squared, x squared plus 1 in here, you'll get the negative on here, but you won't get this subtract. Make sure that you do that. Now, what do I got to do? Well, let's see. That's going to be x squared minus x squared. Do I have any of them left? Nope, they're gone. I have 2xh. Do I have any of that over here? No. So I've got 2xh plus, do I have an h over here? Nope. H squared plus 1. Okay? Does that make sense? Yes? What you have to look at here is, okay, that is what it is. They just plugged it in. Just plugged it in. I don't worry about why it does what it's supposed to do. I just do it. Okay. So, the next question says I'm supposed to find the average rate of change. I'm supposed to find this over h. So now all I got to do is put this here over h. Okay. Is it over h? What else can I do with it? Can I do anything else with it? I mean, we had that, plugged it in, and that's all I got out of this. Okay? I just realized I screwed up one thing. And this happens. I forgot one number here when I wrote it down here, didn't I? Okay. And stuff like that's going to happen. So, because I realized that, oh, gee, things aren't canceling out the way they're supposed to be. All right. Now, for those of you that just like putting answers down and don't like writing in everything, you're going to be completely clueless and lost. Because I'm not going to be able to see where the error was, nor are you going to be able to figure out where the error was. Because I know that this 1 should be gone. Why should it be gone? Well, if I got a plus 1 back here minus a plus 1 over here, that's gone, right? Because I've done this enough in my lifetime that I know that something went wrong. Okay. But if you look up the answer and say, well, hold a sec, that's not supposed to be there. What did I do wrong? You got to understand how to go through and fix the errors. So now, I can factor out an h. So I factor out an h, and I end up with 2x plus h all over h. Guess what happens? They cancel out, and we end up with 2x plus h is our rate of change. A lot of these formulas that you're going to get to deal with look just flat out ugly. A lot of stuff cancels out. Once you start plugging it in, you're going to see where things cancel out, fall out. But you have to go through the process of writing it all out. Otherwise, it just simply is not going to work for you. That's just the way it is. So, let's continue on here a little bit. Now, approximately linear data. I kind of alluded to this a little bit before. When you start going and taking a look at actual, real, live data, that looks fairly linear, doesn't it? If you take a look at the data here, That's going up every 2 years. Is this going up by the same amount at all times? No. A little bit of variation. I mean, it's fairly close. Okay. I mean, it's less than 200, a little less than 200. You know, here, you got to be careful about it. So, one of the ways that you can deal with this stuff is plot it out, pick a couple of points. You could use the endpoints, come up with a slope. Pick a point, come up with a line. Okay. All it is. Now again, this is one of these situations that, well, gee, which point? Tell me which point I should always pick. I can't. In this data here, I mean, it could go from 1990 to 2008. That looks fairly good, right? But it actually looks better if I would take 1990 to 2006. I'm going to get slightly different stuff, but it looks like a slightly better line. This looks a little flatter here, a little flatter there. It doesn't matter. Pick points, come up with a slope. Pick points, come up with the equation of a line. And it'll model it. Okay. So, actually we could use a calculator to do this more often than not. But I'm not quite going to show you how to do that quite yet. It comes up a little bit later on. Okay. So, here you're up for the assignment, and if you got questions, by all means ask.